Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, today we will be solving the next question. Question number 16. This comes in paragraph from match the following in paragraph. We have three questions in this paragraph, 16, 17 and 18, and we will start with question number 16. So let us begin with question number 16. Students, let us solve the next question of this paragraph, which has three questions, 16, 17 and 18. So the first question will take, let us first read the question. An ideal gas is undergoing a cyclic thermodynamic process. There is a thermodynamic process which is a cyclic process, and an ideal gas is considered in different ways are shown in corresponding PV diagram. So we have three columns given, column 1, 2 and 3. The column 1 represents the work done during the process 1 to 2. You can see here 1 to 2, 1 to 2. In column number 2 we have isothermal, isochoric, isobaric and adiabatic process, and in column number 3 we have the PV diagram. The P is in y-axis and V is in x-axis. Now consider only the path from state 1 to state 2. Consider the path from state 1 to state 2. So we'll consider only that is given in the diagram 1 to 2, 1 to 2, 1 to 2, 1 to 2. Okay. The equations and plots in the table have standard notations. The equations and plots in the table have standard notations as shown as used in thermodynamic processes. Here gamma is the ratio of specific heat capacities at constant pressure and constant volume. So this gamma is Cp over Cv. It is called adiabatic constant. Now the number of moles in the gas is n. So n moles of ideal gases have been taken. Now first we'll see the question number 16 for this paragraph. So question number 16 says, which of the following options is the only correct representation of the process in which the change in the potential energy, or this is the change in this, because this is the change in internal energy. This represents change in internal energy because from first law of thermodynamics, the heat that I am supplying is used in two ways: increasing the internal energy or change in internal energy plus the work done by the process. So this delta U is represented with delta Q minus delta W, and this delta Q minus delta W is P delta V. So this delta U is this. So this delta U represents the change in potential energy. So this equation is given in the question. This is from first law of thermodynamics. Now you have to see which of the following four options is correct. So now we have to see all the options given and find out which one is correct. The first option for option number 1. For option 1, we have 2, 4R, 2, 4R. So we have to check that 2, 4R. What is that 2, 4R? 2 from column 1, this I will take, 4 from here, column 2, and R from column 3. So this combination is given in first one, 2, 4 and R. We'll see whether this option is correct or not. We have to find the change in internal energy. So the change in internal energy is delta Q minus P delta V. So here it says about the work done during the process 1 to 2. So work done during the process 1 to 2 here is actually P if I take P common, it was V1 minus V2. This I can write as minus of P V2 minus V1. This is our P delta V, and this is minus. So this is work done on the gas, and this work done is possible only in case of isochoric this process, which is constant, that is called isobaric process. P should be constant. So if I have P constant, then I can write P delta V as the work done. In this process 1 to 2, in this option 1 to 2, P is not constant because P is changing from higher pressure to lower pressure. So this option is not correct because it talks about the work done, and this is adiabatic process, this is not the work done. So this option is not right. So the first option is wrong. This option is not right, this option is wrong. Let us take the second option, 3,3P. If I check the option 3,3P, 3 from here and P from here, the work done is 0. He says that for this the work done is 0. The work done is not 0 because you can see that the volume is expanding from 1 to 2. Here is having certain volume here, and 1 here certain volume here. There is an expansion in the volume. The volume increases. So when there is an increase in volume, you cannot have work done 0. So this option is also wrong. And the second thing is that this is pressure is constant. So this process is isobaric process, but the volume is expanding. So this is not the answer. So option number 2 is also not right because the work done is not 0. There is some work done in the process. Now let us see the third option, which is 2, 3S. 2 from here, 3 from here, and S from here. 2, 3S. So here work done is this one. 3, this is isobaric process. In isobaric process, the pressure is constant. And if you see here, this is not the isobaric process because the pressure is changing. Because the pressure here is changing from 2 to 1. Here the pressure is something else, and here the pressure is something else. So pressure is different. So therefore it is not isobaric process. So therefore option number 3 is also not right. So obviously this should be the correct answer without solving, but then we'll check it. 2, 3P. If I see 2, 3 and P, then what will happen? This is a isobaric process. 2, 3P. 2, 3P here. Isobaric process, pressure should be constant. Here the pressure is constant. You can see that the pressure is constant. And so this 2 is matching. And third one is this one, you have to find whether the work done is this or not. In isobaric process, the work done in the expansion from 1 to 2, the work done is P delta B. This is the work done by the gas. So work done for option number 4, work done by gas, is P delta V, which is P V2 minus V1. And work done on the gas is minus P V2 minus V1. So the work is done on the gas, and it is expanding from this volume V1 to certain volume V2 under constant pressure. So work done on the gas is minus P V2 minus V1, and here also it is P V2 minus V1. So this answer is correct. Okay, thank you.